Welcome to this lesson, where we'll be learning how to interpret and solve everyday problems using our knowledge of trigonometry. Let's look at our first case. One day, Ashabi and her friends were playing football in her backyard when the ball got stuck at the top of the roof of her house. Ashabi wanted to pick the ball from the roof, but she couldn't climb the wall because there was nothing to hold on to. However, she had an extendable ladder in the house. She brought out the ladder and put it leaning against the vertical wall of the house. If the ladder made an angle of 45 degrees with the ground and the foot of the ladder was 3 meters from the wall, find the length of the ladder. To answer this question well, let's draw a sketch. If we look carefully, we can see the outline of a triangle. We can bring this triangle out so that we can solve this question without distractions. The question requires that we find the length of the ladder. Let us represent the length of the ladder by the letter L. The triangle is a right-angled triangle since the question tells us that the ladder is leaning against a vertical wall. That corner marks the right angle in this triangle as shown in the sketch on the screen. From the triangle on the screen, we can see that L is the hypotenuse since it's the longest side and it's the side directly facing the angle 90. Also, we can see that 3 meters is the length of the side adjacent or beside the given angle, that is, angle 45 degrees. So, this question involves the adjacent and hypotenuse of a right-angled triangle, that is, A and H in our acronym SOHCAHTOA. That means we will apply the cosine function in this question. Thus, we'll have cos theta equal to adjacent over hypotenuse. So, we'll have cos 45 equal to 3 over L. If we cross multiply, we'll have L times cos 45 equals 3. And that will give us L equal to 3 over cos 45, which becomes 3 over 0.7071. And that gives 4.24. Therefore, the length of the ladder Ashabi extended to reach the roof of her house to fetch her ball was 4.24 meters. Hope you got that. That is how you apply your knowledge of basic trigonometry to an everyday problem. First, you sketch a diagram describing the given problem or situation if you are not given a diagram in the original problem. Next, you mark out any right angles in the sketch. Then, you show the sizes of other angles and the lengths of any sides if they are known. Then, you mark the sides and all angles you have to calculate. Look critically at the information you have in your sketch and determine if you need to create right triangles by drawing extra lines. For example, by dividing an isosceles triangle into 2 congruent right-angled triangles. Finally, decide whether you will need the sine, cosine, or tangent function. Then, solve any equations you have. So that is how you handle word problems or applications of trigonometry. Bye for now.